looked at a mountain and wondered how it got there, or held a crystal and asked, what exactly is this? Welcome to the world of geology, the study of Earth, its materials, and the processes that shape it. Geology is the science that explores the Earth's structure, composition, and history. It helps us understand how the planet has changed over billions of years, from erupting volcanoes and shifting continents to the formation of precious minerals deep underground. But it's more than just rocks. Studying geology helps us find and manage natural resources like water, oil, and metals, understand and predict natural hazards like earthquakes, landslides, and tsunamis, learn about Earth's past climate so we can better understand climate change today, even guide us in the search for life on other planets. Now let's break it down. What is a mineral? Okay, a mineral is a naturally occurring inorganic solid with a specific chemical composition and a definite crystal structure. A rock, on the other hand, is a solid mixture of one or more minerals. Basically, rocks are made up of minerals. Okay, so one or more minerals present together will make a rock. Okay, think of minerals as the ingredients and rocks as the final recipe. So by the end of this course, I'm sure you won't call a mineral a rock, and make sure that rocks are made up of mineral, but a mineral is not a rock. Okay, they're different. To be classified as a natural mineral, a substance must meet now 4 key criteria. A, naturally occurring. It must form in nature, not in a lab. Okay, so it cannot be a synthetic diamond. Something that's formed, a lab-grown diamond, will not be considered a mineral. Second, inorganic. It cannot be made of living or once living materials. 3, it has to be solid at room temperature. 4, definite chemical composition and crystal structure. It must have a specific chemical formula and atoms arranged in an orderly pattern. If it doesn't meet all 4, it's not considered a true mineral. Minerals might look simple on the outside, but their atomic structure is what gives them their unique physical properties. Inside every mineral is a repeating arrangement of atoms forming a crystal lattice. The way atoms bond, whether they share, donate, or pool electrons, influences the hardness, cleavage, and other properties. And these are physical properties that I will be talking about and demonstrating with individual minerals. But let's just go through those physical properties. These atomic structures control the physical properties we use to identify minerals, including hardness, how easily it scratches, cleavage, that's the plane of weakness. When a mineral falls, how will it break? And that's all related to the atomic structure of the mineral. Luster, how it reflects light. Color and streak, the color of the powder of the mineral. Streak is nothing but the powder that's left on this porcelain white plate. For example, diamond and then density and more. For example, diamond and graphite are both made up of carbon, but their atomic structures are completely different. That's why diamond is the hardest mineral while graphite is soft and slippery. So when we study geology, we are not just learning about rocks. We are uncovering the Earth's history, understanding its future, and learning how deeply connected we are to the planet beneath our feet. Okay, let me introduce you to the first physical property, which is color. Now, color is simple. It's the color of the mineral. Okay, it's not the best identifying property, but we'll start with it. For example, this unknown mineral, the color would be white. Okay, for example, the color for this unknown mineral would be silver. This obviously would be green. Now let's move on to the second, which is a very peculiar property of a mineral, is the streak of a mineral. Streak is the color that is left behind by a mineral when it's rubbed against this streak plate, which is a porcelain plate. Now see, I'm going to rub it. You see? Now this is white. It's probably, it's just the mineral scratching on this streak plate and giving like a white powder. It doesn't have a color. So I'll say no streak present. Let's look at another mineral. use this mineral and see the streak. Okay. Color. The streak color of this mineral is almost cherry red or brown. Okay, so that's the streak of a mineral. And then let's move on to luster. Luster is the shine of a mineral. Now, since we want this mineral, this is not very shiny. We'll call it a very dull, earthy luster. Whereas this mineral here, it'll be very smooth and silky. It can be silky luster or vitreous luster. Something like this will be metallic. It shines like a metal. So basically, lusters are two types: metallic and non-metallic. This could be classified as a metallic luster too. Now let's move on to the cleavage of a mineral. Now, the way the atoms are arranged will decide how the mineral will break. For example, of course, don't drop the minerals that you have, but if they fall or if they were eroded, they would break in a particular way. Okay, and that is the cleavage. The cleavage in mineralogy means a plane of weakness. Okay, for example, this mica mineral that I see, it'll only break like planes. Look at these plane of weaknesses here. It will not break like this diagonally. No, it'll only break in basal form. So that is the cleavage of this mineral. It's only peculiar to mica. It's basal. Let's see another mineral cleavage. I'm going to show you this mineral. It's a very small mineral, but it shows you. It'll show you two planes. Those two planes here, those are your cleavage planes. So you say two sets of cleavage present. I'll show you more peculiar like this one. This one is a green color mineral, fluorite. You'll see it's broken here, one plane, and then another plane that's here, and then you'll see another plane here. So it's almost 2 to 3 sets of cleavage. Now there will be minerals that will not have any cleavage planes. For example, this you just say that it's got no cleavage present, right? So it's just rounded. So then that one doesn't have any cleavage. Now for hardness, of course, there are thousands of minerals, and some minerals are soft, like a talc mineral that is extremely soft as compared to a harder mineral, the hardest mineral being diamond. Okay, we do not usually find diamond in our hardness kit. So let's move on to some things that we know. Our fingernails can do a scratch test. Then this penny, then we have a knife that we can use. We can use a nail. So if they scratch with your fingernails, supposing this mineral scratches with my fingernail, see it leaves a powder, then the hardness is 2.5. And if the mineral scratches with a glass plate, then its hardness is, look at that, it's leaving some, its hardness is greater than 5.5. Okay, so glass plate, and then anything if it scratches by a finger with a nail, then its hardness is anywhere between that. This is harder, it's not scratching by a fingernail, so this maybe scratched by a harder surface. It's not getting scratched by a glass plate too, so this is hardness greater than 5.5. Let's see if we can scratch something with a knife. This mineral. Yeah, so a knife can scratch it, so this hardness of this mineral will be around between 2.5 to 5.5. So these are generic ways to find whether it's a soft mineral or a hard mineral. It's another way to identify minerals. So you write the color of the mineral, you write the streak, you write the luster, you write the cleavage if it's present or not, the hardness of the mineral. You can also weigh, like lift the mineral and give an idea which one's tough, which one's more heavy, which one's less heavy. Another one that I like is the HCl test. So if the mineral is made up of carbon, it will show bubbles. Not all minerals are made up of carbon, but we will see. If I will put this on, say, a calcite, it will show bubbles. No, I don't see anything. So this looks like a white calcite, but my HCl test doesn't prove it. Okay, see. This one shows bubbles. This is effervescence. But this mineral is calcite, or it's made up of minerals that has calcite in it. So that is a great way to identify another mineral. We spoke about metallic, non-metallic, and now we can try it. We can use our tables, and we can use our lecture notes to identify an unknown set of minerals.